Today we want to take a look at arithmetic sequences and series. To be arithmetic means that you have a common difference, which means that you're adding or subtracting the same number to get from one term to the next. If we take a look at our two examples, the first example, if I'm going from 15 to 8 to 1 to -6, I'm subtracting 7 each time. So my common difference would be -7. For the second one, 6, 10, 14, 18, I'm adding 4 each time, so my common difference would be a +4. Our rule to find any number in our list is a sub n is equal to a, which is the first number in my list, last year we wrote it as a sub 1, plus n minus 1 times our common difference. So we want to use this rule to help us find any number in our list. Looking at our first example, number 1 here, we're given that our sequence is 15, 8, 1, -6, the same one we did in our example, which means that if I'm going from 15 to 8 to 1 to -6, my common difference is -7. If I want to find the fifth term in my list, the next number, well then I'm going to take the fourth number, -6, and subtract 7 from it, and my a sub 5 would be -13. To write a rule for this, I'm going to take my rule, a sub n is equal to a plus n minus 1 times d, and I always plug in the first number in my list, which in this case is 15, my common difference, which is -7, and I leave n in the problem so that I can write an equation for any n. Once I distribute my -7 and combine my like terms, I get that a sub n is equal to 22 minus 7n. If I were to rewrite this into y equals mx plus b, notice that I have y equals mx plus b. I have the equation of a line with a slope of -7. If I want to find the 100th number in my list, then I'm going to plug 100 in for my n, and I can see that a 100th number in my list is -678. An arithmetic sequence will always make a line. So if I think of my n as my x, my input, and my a sub n is my y, my output, then I can go ahead and graph the points 1, 15, 2, 8, 3, 1, 4, -6, and I can see that I'm going to have the line with a slope of -7.